So let's look now at how you can subset your data and also how you can deal with missing cases, missing values. So I've cleared the console here and cleared the environment. So I'm going to rerun all the code that I did in the previous video. This, of course, is why a code-based software like R is better than a menu-driven one, in that you can rerun things instantly. So I'm just going to highlight all this code here down as far as what I had before, which is to there. Then I'll just press run. And of course, there we instantly get all the results that I had before, the charts, everything very instantly. Okay, so I'm in fact going to clear the console again now by pressing Control L. So I want to have a look at how you could, up to now we've been dealing with all the data, but sometimes you might want to subset it, particularly if it's a particularly large data set. You might want to subset to only concentrate on certain variables or certain cases. With this very small sample data set I'm using here, that doesn't really apply much, but in a realistic case of a very large data set, subsetting and filtering could be useful. So let's first of all look at how to select specific columns, specific variables. Well, the syntax you use here is what's called the matrix syntax in R, because a data frame is a spreadsheet, which of course is also a form of matrix, a 2x2 array of data. So all you do is you put obviously data, and then in brackets you put firstly a comma, and the comma means I want all the rows, all the cases, and then as a little vector you put the variables that you want. So this is going to choose all 20 rows, but only gender and usage. It will ignore the site variable. So if I enter that, you'll see it's exactly what I get. And of course, I would probably save that into, assign that to a variable so that I could use it later if I was going to do some analysis on this. Another way you can choose columns is to, instead of specifying the variable name, specify the column numbers. And they're numbered from 1 onwards, starting with 1. The first one on the left is column 1, and then the second one 2, and column 2, and so on. So if I specify here that I want all the rows and columns 1 and 3, that should give me gender, which is the first column, and usage in hours per week, which was the third column. And finally, another final way you could do it is by specifying that you want, say, columns 3 to 6 or something like that. So here, for example, again, the comma to say I want all the rows, and I want columns 2 to 3, which in my case, of course, will simply be 2 and 3. But obviously, if you specified 2 to 6, you'd get columns 2, 4, 5, 6. Notice that you specify as 2:3. And that, you can see, gives me all the cases in just rows 2 to 3. So that's how you can select specific columns. You might want to select specific cases, specific rows. So we can use a similar notation here. So here, you can probably guess what this is going to give me. It's going to give me rows 5 to 13, and this time the comma at the end means all the columns. So it's going to give me 5 to 13, including all the variables. Like that. So we got rows 5 to 13 and all 3 variables. And finally, of course, you might want to choose specific rows and specific columns. So here, obviously, we can combine these two forms of syntax here, as I've done here. So here I'm getting rows 5 to 13, but this time only the gender and usage variables. Just like that. So as you can see, it's very easy to subset onto just specific columns, specific rows, or a combination of both. Another way that you might want to subset is by filtering the data according to some condition. So for example, you might only want to look at those cases where the gender is female. For this, you use the subset function combined with various conditions which can make use of Boolean operators like and or and not. So here, for example, as you can see, I'm going to choose a subset of the data where the gender is equal to F, to female. Notice that you use a double equal sign here, not a single equals. It's a double equal sign. So this should simply choose all those cases where gender is equal to F. Like that. And of course, it gives me all the rows, all the columns, I should say. Now, you can say use Boolean operators to have more complicated conditions. So here I'm choosing those cases where gender is male and, so that's the Boolean operator and here, that ampersand equal to Twitter. So there we are. Those are those cases where the gender is male and the site is Twitter. Another Boolean operator is or, and for that you use this line here. I don't know what that's actually called as a symbol. It's but you'll find it on your keyboard. It's just that straight vertical line. So here I'm choosing a subset of the data where site is Facebook or site is Pinterest. And as you can see, that gives me that. Just Facebook or Pinterest. The other Boolean operator is not equal to, which is this symbol here, an exclamation mark followed by an equal sign. So here, as you can see, I'm choosing those cases where the site is not equal to Twitter, so it's equal to Facebook or Pinterest. So in fact, that should give me the same as this one here, shouldn't it? And indeed it does. So that's filtering on the categorical variables. What about filtering on a numeric variable? Well, I can easily do that. So here, as you can see, I'm going to choose those cases, those rows, where the usage HBW value is greater than 40. So here, obviously, you can use obvious arithmetic operators, greater than, less than, greater than, equal to, less than, equal to, and equal to. And of course, you could combine them with these Boolean operators as well. So this will give me all those cases where, as you can see, it's greater than 40. So very easy to filter and to subset your data set as required. Let's say with a small data set like my sample one here, you wouldn't particularly want to do that, but with a large data set, you probably would. One final thing here is, well, what about adding additional variables to my data set where those new variables are based on or some transformation of one of the existing ones. So for example, here how do I add another variable to my data set? Well, it's very easy. You simply indicate the new name here. So you put, so as if it's just the same syntax as if you were choosing a particular variable, but you use a different name. So data, $, and then the new variable name equals, and then just some expression to create that variable. So I'm indicating that I want to multiply the data usage in hours per week by 9 here to give me this new variable. So I'm kind of assuming that they typically are on for 9 hours a day or something like that. Like that, and then if you display there, you can see it's added that, and it's multiplied each one by 9. So very easy to add additional variables like that. Okay, let me just clear the console here. There's one final thing I think which is useful to look at here, and that's how would you deal with a data set which has missing values? Because with a realistic data set, that could be the case. So now there are a number of ways you can do this. I'll just look at a couple of, I think, fairly easy ways of doing this. So what I've done here is I've created a new data set here. It's the same variables as before, but I've included some missing values in it. So I'm going to read that in as usual. And then if we look at the structure of it, then that doesn't really indicate that there are missing values. It simply tells me now that there are 30 observations rather than 20, still the same three variables. But if you look at the summary, then you will see, in fact, we can see that it does have two missing values in the usage variable. And it looks like there's a missing value or a blank in the site variable. Now, when you import the data using read.csv, provided you've used this strings as factors equals true option, which you should if you've got category variables, it will place an NA, which is the missing value notation, in the data set, but not always. But it's not always the case that it does that, because you can see here it's just left it blank. You'll see this. Let me show you the data set. You'll see what I mean. So as you can see, on these two missing values here on the usage variable, it has indicated NA, which is useful because we can then exclude those. But for here, where there's simply a blank, it hasn't put NA. So first of all, let's exclude these rows here where there's a missing value. You can do that using the complete.cases function here. So what you do is you put the name of the data frame, the variable that the data frame is in, which was data_1. Then in brackets, in square brackets, you put complete.cases, and then in round brackets, the data_1 again, and then a comma to make sure you get all the columns. And then, of course, it's useful to assign that to a different variable. So this will remove rows 13 and 17. And if we can check that, there we go, row 13 has gone and row 17 has gone. But what about this one here? Well, if it's a small data set like this where you can see where the missing value is, we can easily exclude that row, as I'll show in a moment. What if it was a much larger data set where it would be quite difficult to scroll through to find where some blanks were? So you can deal with missing values easily enough, where it actually has put NA in. But if it doesn't put NA in, how do you find these things? Well, say with a fairly small data set, you could just look at it and find it. What if it's a much larger one? Well, obviously we could use the subset function to identify that. So I'm going to put subset data_1 and I want it to return the cases where site is an empty string, which is effectively what this is. So that should return simply row 8, which it does. So that's enabled me to identify the rows, in this case just one, where there's blanks. So I can now exclude those. How do you do that? You simply use the same notation, matrix type notation I used up here, but you use a minus sign. So this is saying I want those all the columns, hence the comma there, but I want to exclude row 8. So that's going to return everything apart from row 8, which is what I want. So let me run that and then check that it worked. And there we go, row 8 has disappeared as well. So as you can see, that's cleaned up the data set very nicely, got rid of all the missing, the cases where there's missing values, whether those missing values have been indicated by NA or whether they're just blanks. And so you can now proceed to analyze it in the ways I've been looking at.